Okay, welcome back. Section 1.5, Day 2. Here's the 2 learning targets we'll be covering today. I can determine the intervals in which functions are increasing, decreasing, or constant. That's not on your copy, but we will be addressing that as well. Something that should look familiar from Algebra 2 as well. And I can determine the relative minimum and relative maximum values of a function. Okay, so let's get started with those two. All right, so for a function to be increasing, this is kind of what you're looking for. Here's the definition. A function, I'm going to abbreviate the word function with just fx, is increasing when the y values increase from left to right. All right, so a function is considered decreasing. Just the opposite happens. And we do have to focus on the y values, not the x values, okay? So function is decreasing when the y values go down or decrease in value when looking at the graph from left to right. Okay? And a function is considered constant when the y values remain constant, or for a different word, remain the same from left to right. Okay, so that's what we'll be looking for. Zoom in a little bit if you needed to pause that and catch up. Now would be a good time to do just that, but I'm going to keep moving. All right, relative maximum. It's the max y value for I'm going to use the word again, it's basically a relative area. Because some of these graphs will, have arrows and move on forever and go up, and we don't want to count that as a maximum. We're really just kind of looking for turning points. Okay, so let me show you here in just a second. Let's get this definition down too. Relative minimum is the minimum y value. The min y value, once again, for a relative area. All right, so if I just gave you a quick little generic graph over here, let's just say the graph was kind of doing something like this. You may want to add this as well. Okay, now, this maximum y value goes on to positive infinity, but that's not going to be the answer. You kind of look for the turning points. So for a relatively small interval of x values, what's the max y value? So it peaks right here at this spot. So this is called a relative max, turning point, and then this dips down to a relative minimum, okay? Right there. Wherever that coordinate would be, we'd identify as the relative max and the relative minimum. Okay, easy enough. All right, let's go ahead and take a look at number 8 and 9. Determine the open intervals on which each graph is increasing, decreasing, or constant. And sometimes they're closed intervals. Okay, so it could be open or closed. These directions are a little misleading. But when you see them asking for increasing, decreasing, or constant, this is what we need to do. Okay, once you write this down, there's a couple of real basic rules for expressing these types of intervals, the increasing, decreasing, or constant. Okay, pause this for a moment as you're writing that down. Okay, rule number 1, always use the x values when describing. Okay. Here's the other rule you got to be careful of. Never use brackets. Okay, because we'll be using the interval notation that we were using Friday. So never use brackets, only parentheses. All right, and I'll explain that when we get into number 8. Okay, so when is this increasing? A good way to label this is just kind of put the word increasing or abbreviate it like this. And let's answer it. When are the y values increasing from left to right? Okay, so the y values are going up on this part of the graph, right? From -2 to -1 to 0 to 1 to 2. And then it turns at this relative maximum. So this is an increasing interval. So we always use the x values when describing this. Okay, so if I kind of put a little dividing line here to help you see it. What's this x value way over here? We're at -infinity. That's where this needs to start. So -infinity up to the x value -1. So it's increasing from here to here. Okay, now I know we see a solid dot there, but you don't use brackets to include it because it's in a point of transition. It's not increasing at this point and it's not decreasing. It's in a point of transition. So that's why we use this general rule of never using brackets for this type of problem. Okay, even if you see a closed dot, even if you see an open dot, doesn't matter. Parentheses. Okay. Now it's also increasing at another interval. All right. Well, let's just go in order, right? So from here, now it transitions to these y values are now decreasing from here to right here. So what are these x values? So it's decreasing from an x value of -1 to +1. Okay. And then at this relative minimum, once again, we don't want to include +1, even though we see solid dots, because it's transitioning. So parentheses, and then it starts to increase again, right? From -2 to -1 off to +infinity. So what are the x values? Okay, the x value is 1, so the x value keeps going this way, right? +infinity. So it's increasing. I'm going to add another answer here. From 1 to infinity. Okay. It says constant. There is none, so we could just keep it blank, or if you wanted to just make sure, do something like this, there are none of these intervals, okay? All right, why don't you pause the video and try number 9. Okay, here we go. So it is increasing. These y values are clearly going up. Now, I know there wasn't an arrow here. Sometimes these computer graphics, you got to assume if they slide it off the coordinate plane, they're assuming that there's an arrow here and here. So if that threw you off, sorry about that. If you look at this, it does say t is less than 0, so they're trying to tell you that it continues this way. Same thing, t greater than 2. Anyways, you can assume that it continues on just like we had to assume over here. Increasing, so what's the x value way over here? It's going to be -infinity, right? It's coming in from -infinity, and then it stops at this x value of 0. Okay, once again, we see a dot, but it doesn't matter. We're using parentheses. Now from here to here, these y values are constants at the y value of 1. So this is our constant interval, which we're going to say is from an x value of 0 to an x value of 2. Okay, 0, 2. All right, and then as these y values start to go back down, so what are the x values? Picking back up at 2 to, it's going to continue forever, so on to positive infinity here. All right, so there's your feedback on number 9. These take a little bit of practice, so we're going to throw a bunch of different looking graphs at you to get used to these types of problems, okay? All right, let's look at 10. Identify the relative maximum and the relative minimum of the graph in problem 8. Remember, just looking for turning points. These don't make these more difficult than what they are. Okay, so my relative maximum is right here. Turning point. The high turning point, -1, 2. The relative minimum, 1, -2. Okay, that's it. Now they may ask you, what is the minimum y value? If they use that phrase, then they're just talking about the y value. That is the min y value. Or they might say, what is the max y value in the relative area? So answer it by saying 2 there. Okay, let's go ahead and take a look at how we do that with our calculators. Using the graphing utility to approximate to 2 decimals any relative minimum or relative maximum of the function. Determine the open intervals in which they're increasing, decreasing, or constant. Okay, so I'm going to throw this in my y equals real quick. Clear what I have in there. If you don't have one on you right now, just watch these steps, and then you can try it once you have a graphing utility in front of you. Okay. Okay, so here's our parabola. To locate the maxes and mins, we're going to use the trace feature to get it going. We can clearly see a relative minimum right here. So if I hit trace, nope, my stat plots are on. So if this happens, it's saying quartiles there, I got to turn my statistic plot off. It's giving me problems right now. So I'm turning that off and then go back to graph. Okay, so we hit trace, we get this spider looking cursor here. So what you want to do is go to the left of your max or min, hit calculate, so that's second trace, and then we can find the minimum of the graph right there. Okay, it's going to ask for left bound, so we hit enter. Should make a little mark for you to make that left boundary. Scroll to the right now to make your right boundary, hit enter, and now it's going to find the minimum between these 2 spots. It's a pretty accurate guess. It's not really guessing. All right, so it's going to give us a minimum. Here's my coordinates. Okay, I'm just going to go to 2 decimals. It should be plenty. All right, so I'm actually going to copy this quick little sketch right down here. I got to move my calculator out of the way a little bit. So this is just going to help us answer the question. It doesn't have to be super accurate right now, okay? So this relative minimum here is the coordinate -0.37 and -1.56. Okay. All right, and this is our relative minimum here. Relative minimum. All right, so now that we have that, we can go ahead and determine the intervals in which the graph is increasing, decreasing, or constant. Okay, so it's decreasing from here. These y values are clearly going down. So what's the x value way out here I'm starting with? -infinity. Up to, what's this x value? It's right here, -0.37. Okay, and then it's increasing from this x value of -0.37 to positive infinity. Okay. All right, 12 is for you to try. Go ahead. Okay, here's your feedback. Here's your relative maximum right here. Here's your relative minimum right there using that trace feature. Okay, so here's the solutions. It's increasing from here, -infinity, to this x value of -0.67. Then it starts to decrease from this x value to this x value. And then it turns back around from 2 to infinity and increases. Okay, all right, review this video as needed. Have a good day.